This video is the second of a series titled Groasis Waterboxx, Providing Solutions to World Problems. Pieter Hoff, the inventor of the Waterboxx and founder of AquaPro, had worked for 35 years as a breeder, producer, and trader of lilies, gaining an extensive expertise in the floricultural industry. His company, Hoff Quality First, with offices in the Netherlands, China, and South America, focused on innovations and developments. Stringent testing with new varieties was conducted worldwide at his clients' sites before the new products were launched commercially. In 2003, Pieter sold his flower bulb company, founded AquaPro, and has been dedicating himself nonstop to his invention of capturing water from the air. In part 2 of our conversation, Pieter explains his entrepreneurial efforts that led to product development, testing, prototype modifications, and retesting following the birth of his ingenious idea of collecting or capturing condensation and rainwater in the dry areas of the world.
So in Italy, you got the inspiration to capture the condensation from the air so that it doesn't go to waste. And then your background was this tremendous world travel from your previous business as a lily breeder, grower, and exporter. And you observed, and your clients told you that the irrigation water that they've been using for centuries was the water table, the groundwater table, was slowly reducing because there's this incredible waste due to evaporation of through the drip irrigation system. Wow.
Okay.
Yeah, my goodness. Okay, so that was the idea, and then how did that idea then turn itself into this product, the Waterboxx?
What I did was, so in 2003, I started to study why is that condensation, how does it work, and then how do you catch it. You know, you have many wrong ideas, but everybody, for instance, thinks iron is cold, so you should have an iron cover. Because also people see the condensation on that car. So they think, you know, iron is very good. So I started with iron extra, made an iron cover. But then I didn't have condensation. So I thought, why do I have condensation on my car and not on my iron cover? Then you start to understand the principles. It's not about the iron, but it is about, you know, the capacity of heat, or let's say the word energy, that material can absorb, and the speed of which it can lose or absorb energy. Those are the factors. I came on plastics, which were far better than iron with condensation. And I did small piles, and then once I measured my quantity of condensation, and once we only had 1 millimeter of rain, which is really nothing. To give for your American listeners, 1 inch of rain is 25 millimeters, so it's really 1 millimeter, very little, but that's 1 liter per square meter. And I had 1 liter that morning, and I realized, oh wow, of course, rain. Why didn't you think about it? So then below my cover, I made a box. So it was actually a process. But then, of course, you have the box, and you think, okay, now I have the box. How do I bring it from the box to the plant? We have thought a few years about good solution, which in the end became a big. And you have other challenges. For instance, you have water in a box, but you have 50 degrees Celsius in the desert. How can you make an opening that is capable of capturing a rain shower, which is very heavy, but then is closed for the water to evaporate? While developing, you meet very nice challenges to solve. And now, let's say in the year 2009, I had solved them through making various prototypes. And in 2009, we decided, okay, it's working. I had done 4 years of trials in the Sahara Desert, 25 boxes, and I was convinced that it could be successful, so we decided to make the mold, and make 30,000 boxes in the spring of 2007. That's actually how we came worldwide. I tried to find people everywhere who were interested to do the trials with me. And yeah, we send the boxes everywhere. put plants in it, all kinds of trees. And yeah, then the learning process starts. Because
of course.
Then actually you find out, okay, the principle works, but I have so many things to improve. The model 2011, for instance, has been improved on 10 places. Model 2011 was my 10th prototype. So during the years you improve and improve. And it also leads to other inventions. I also found that most of the plants that you buy in the world do not have the right roots. So I found solutions for that also. But that's perhaps a too long answer. I will give you the opportunity to concentrate back on the subject. What I actually did was between 2004 and 2005, I've done trials in Holland. The principles you can learn at home, and it costs money. Then I found, okay, it seems to work, and I got a contact with a university in Morocco, and during 4 years we have cooperated with that university and planted 25 boxes. And from those lessons that we got over there, we have gone to the model that people know now, which we have produced in the winter of 2009-2010, and we made 30,000 boxes. And when we had 30,000 boxes, it gave us the opportunity to really go worldwide, because every valley has its own climate. So you cannot say it works in Morocco, so it will work in California. Let's give an example. In Morocco, you have 65% relative humidity. You have a high production of condensation every morning. But in the Mojave Desert, where we are doing the trials, near Palmston, we have only 7% relative humidity. So you have condensation. The thing that is much more important than I had realized when I started is that yesterday I came from Spain, and we are doing a project there with the University of Valladolid with 32,000 boxes. They do measurements on the temperature, and here is what we heard yesterday, and that is perhaps even more important than water. In the center of the box, the central opening where you plant the plant, during the month from December until the end of February, they have measured each hour with a logger, 1,729 measured points. What they found is this: the temperature outside the box was from minus 9.5 Celsius to plus 37.5 Celsius. So that's a difference of 47 degrees. Inside the box, in the center opening, the temperature only went to minus 3, and because the opening gives shadow, it only went to 18.5. The difference in the central opening was only 21.5 compared to the 47, which means that the plants that grow in the center of the box have very little stress. And also your soil temperature, because of that, is very moderate and doesn't go up or doesn't go down too much.
Right, exactly, which helps the plant's growth, of course. I mean, protects it from these extremes.
Exactly.
At the end of this second part, Pieter is referring to a project in Spain called the Green Desert Project, which is expected to run for 5 years. The project's aim is to convert 63 hectares or 155 acres of bare and desertified land into forest with the aid of the Waterboxx and without the use of traditional irrigation. The project is supported by the European Union's LIFE program, which has been co-financing some 3,500 pilot or demonstration projects, contributing approximately 2.5 billion euros or 3.3 billion US dollars to the protection of the environment since the program's inception in 1992. Other partners are Spanish municipalities and several small firms. Reforestation in the Mediterranean region has previously been posing a number of challenges, such as the need for continuous irrigation, extremely low survival rates of small trees, and great project expenditures. The project sites are locations in 5 different Spanish provinces, which differ in terms of environmental parameters. 1. Their climates range from dry or semi-desert type climate to Mediterranean climate. 2. The types of soil include sand, clay, rocks, and any combination of the three. 3. The height above sea level ranges from just above sea level to mountains of 1,800 meters or almost 6,000 feet. 4. The previous land uses of the sites include abandoned areas, a landfill, a ski slope, regions of burned forests, and agricultural areas. 5. A variety of indigenous tree species are being reforested. The one characteristic common to all sites is that they are arid and that trees, plants, or crops cannot grow without irrigation and often struggle even when groundwater irrigation is being provided regularly. These 5 sites will allow the Waterboxx to be tested and to prove its effectiveness in a variety of challenging conditions, demonstrating its viability. It is hoped that the reforestation without irrigation with the assistance of the Waterboxx will prove to be a success and become a role model for the implementation of similar projects in other locations around the Mediterranean Sea and in other regions with dry, disturbed, burnt, and/or eroded land. Moreover, it is expected that a green economy will be emerging, providing sustainable employment in Spain and elsewhere. We hope that you enjoyed part 2 of the series Groasis Waterboxx, providing solutions to world problems. If you'd like to review and support Pieter's work, please take a look at the information provided in the description section below the video. Thank you.